Hello and welcome to this video lesson about solving one-step equations. So what this video is going to try to do is explain the mechanics and the processes that are happening when you're solving a one-step equation. And now one thing I want to get across before we even start with actual examples is really what's happening with the equal sign. So the equal sign, what that really means is that things are in balance on both sides of it. And so we like to use this idea or this metaphor of like a scale. So you have two things or maybe even like a seesaw or something like that, and you're putting two things on here, and when you have an equal sign, it is perfectly level. And so what we want to do while we're solving equations is to maintain this equality, maintain this balance. And so with one-step equations, I have this neat little visual representation of how all this works. And so what we're going to do is we're going to use a cup to represent an unknown. So for example, let's say we had the equation x plus 5 is equal to 12. Now some of you might be able to look at it and already know what the answer is. But let's focus on what's happening here and how we can, use this idea of equation meaning balance and keeping everything equal on both sides. So what I've done, take my cup, that represents x. I have an unknown quantity of things in there. Then I'm going to take 5 of these little pieces right here, and I'll take 12 of these pieces right there. And so what I have now is an equation. X plus 5 is equal to 12. And keep in mind, as it stands right now, this thing is perfectly balanced. So if this was like an equation, so like that's my fulcrum, this is perfectly equal and balanced and leveled. So now to figure out what x has to be, what we can start doing is taking away these extra pieces. So we take away one from the left, we'll take away one from the right, take away another one from the left, another one from the right, another one from the left, another one from the right, one more from the left, one more from the right, and finally the final one from the left and the final one from the right. And so now all that I have left, because I've kind of removed these from everything, and keep in mind everything's still balanced, is x is equal to all those pieces right there. And so I can count it out. 1, 2, 3, 4, 5, 6, 7. X is equal to 7. And if I look in here, I will have 1, 2, 3, 4, 5, 6, 7. So the answer to this question was x equals 7. And so I like this metaphor of the cup being the unknown because it really helps us to realize what's going on here and how we can subtract things and keep things equal and balanced. And so now let's do another example. Let me get rid of all these pieces. All right, get rid of that. All right, now let's kick things up a notch. And let's say we're dealing with 2x is equal to 10. Now again, you might look at this and know what the answer has to be. But since we're talking about 2x, I'm going to use 2 cups. So instead of saying 1x, I'll have 2x. And I will grab my 10 pieces right here. And so again, what we have is 2x is equal to 10. And what I didn't do this time is put pieces in these cups, because what we're going to do is kind of show you what x has to end up equaling by, again, using these manipulatives to kind of show what happens in equations. So 2x equals 10. Well, that means that these 10 pieces have to go into those 2 cups. So one will go in the blue, then one has to go in the green. Another one in the blue, another one in the green. Keep repeating and distribute these equally among each other, because that's sort of the theme with solving equations, doing things equally. And now we'll focus on just x, being this blue cup here. And so we have 1, 2, 3, 4, 5. We have 5 of those pieces. So what that means is that x would have to equal 5. And so the reason why I wanted to go over this demonstration with these pieces is to show you really what's happening when you're solving equations. And what that is